The universe has always been a place of wonder, but what if everything we think we know about it is just the tip of the iceberg? What if the cosmos holds secrets so profound, so bizarre, that they could shatter our understanding of reality as we know it? From the very fabric of time to the nature of existence itself, future discoveries in space could rewrite the rules of science, philosophy, and even what it means to be human. Today, we're diving into 25 cosmic surprises that could totally transform our understanding of the universe. These aren't just distant possibilities, they're ideas that could redefine our place in the cosmos, challenge the limits of human knowledge, and open doors to realities we've yet to even imagine. And it all starts with a concept so strange, it makes time itself feel like a fragile illusion. Are you ready to explore the unknown? Let's begin. What if time, the very framework we use to measure our lives, isn't as real as it seems? It's a concept so deeply ingrained in our daily routines, from clocks ticking to calendars flipping, that imagining it as anything but solid feels almost absurd. Yet, some of the brightest minds in physics are challenging this very notion. What if time is nothing more than an illusion, a trick played on us by the universe? This is the first cosmic surprise, the possibility that time, as we know it, might not be a fundamental truth but rather a construct shaped by our perception. The idea isn't as far-fetched as it sounds. Physicists like Carlo Rovelli have proposed that time might not flow at all. In his view, the universe could be more like a block universe, where past, present, and future all exist simultaneously. Think of it as a giant cosmic film reel, with every moment already etched into reality. We experience time as a sequence because our brains are wired to process it that way, but in reality, there might be no now, no before, or after. It's a staggering thought, one that could upend everything from how we think about aging to how we understand causality. Quantum physics adds another layer of mystery to this puzzle. Experiments in quantum entanglement have shown that particles can instantaneously affect each other across vast distances, seemingly defying the constraints of time. This phenomenon suggests that time might not be as rigid as we believe. Instead, it could be fluid, malleable, or even entirely absent at the smallest scales of reality. What does that mean for us? If time is an illusion, then our entire existence, birth, life, death, might be part of a much grander, timeless tapestry. But let's bring this down to earth for a moment. How would this revelation change our daily lives? Imagine waking up one day to the realization that the past and future are just as real as the present. Would we still feel the urgency to meet deadlines or chase dreams? Or would we see our lives as part of an eternal now, free from the anxiety of time slipping away? These are the kinds of questions that could reshape not just science, but philosophy, art, and even how we find meaning in our lives. As we wrap our minds around this mind-bending idea, another cosmic mystery beckons, one that's equally perplexing but far more tangible. What if the universe is filled with something we can't see? Something that makes up most of its mass yet remains completely invisible. This brings us to our next surprise, the enigmatic nature of dark matter. We've stepped into the realm of time's illusion, but now let's shift our gaze to something even more elusive, something that's all around us yet completely invisible. Imagine a force so pervasive that it makes up more than a quarter of the universe, yet it slips through our fingers, unseen and unfelt. This is the enigma of dark matter, the second cosmic surprise that could redefine our understanding of reality. Dark matter doesn't emit, absorb, or reflect light, making it impossible to detect with traditional telescopes. Yet, its presence is undeniable. Astronomers first noticed its effects in the 1930s when they observed galaxies spinning faster than they should based on the visible matter alone. It was as if some invisible hand was holding everything together, preventing galaxies from flying apart. This unseen force, this cosmic glue, is what we now call dark matter. But what exactly is it? Scientists have been chasing this mystery for decades, and while we still don't have definitive answers, the hunt is more thrilling than ever. Experiments at facilities like CERN and the Large Hadron Collider are probing the subatomic world, searching for particles that could explain dark matter's true nature. One leading theory suggests it could be made of weakly interacting massive particles, or WIMP hypothetical particles that barely interact with ordinary matter. If detected, these particles could open doors to entirely new realms of physics, potentially revealing hidden dimensions or forces we've never imagined. To help visualize this, think of dark matter like the wind. You can't see it, but you know it's there when you watch leaves rustling or feel it brush against your skin. Dark matter works in a similar way. It doesn't interact with light, but its gravitational pull shapes the cosmos, guiding the formation of galaxies and sculpting the large-scale structure of the universe. Without it, the night sky as we know it wouldn't exist. The implications of uncovering dark matter's true identity are staggering. It could lead to the discovery of entirely new particles, rewrite the laws of physics, and even challenge our understanding of the fundamental building blocks of reality. Imagine unlocking a cosmic toolbox filled with tools we didn't even know existed. This isn't just about solving a scientific puzzle, it's about glimpsing the hidden machinery of the universe itself. As we ponder the mysteries of dark matter, another tantalizing possibility emerges, one that stretches the boundaries of imagination even further. What if our universe isn't the only one? What if there are countless others, each with its own set of physical laws, its own version of reality? This brings us to the next cosmic surprise, the mind-bending concept of parallel universes. What if the universe we see, with its galaxies, stars, and planets, is just one page in an infinite cosmic library? This is the heart of the multiverse theory, a concept that suggests our universe might be one of countless others, each with its own unique set of physical laws, history, and even versions of us. The idea of parallel universes has long been a staple of science fiction, but what if it's more than just a plot device? What if it's a real scientific possibility waiting to be uncovered? This is our third cosmic surprise, the multiverse. The multiverse theory isn't a single idea but a collection of hypotheses, each offering a different perspective on how multiple universes could exist. One of the most well-known versions comes from the work of cosmologists like Max Tegmark, who describes a mathematical multiverse. In this view, every possible mathematical structure exists as its own universe, meaning there could be realities where gravity works differently, time flows backward, or even where the laws of physics as we know them don't apply at all. Tegmark famously said, "Our universe isn't just described by mathematics, it is mathematics." If he's right, the multiverse isn't just a speculative idea, it's a mathematical inevitability. But how could we ever prove something so extraordinary? Scientists are already looking for clues. One possibility lies in the patterns of gravitational waves, ripples in space-time caused by massive cosmic events like colliding black holes. If our universe has ever collided with another, the imprint of that collision might still be detectable in these waves. Quantum mechanics also offers tantalizing hints. Certain quantum experiments have produced results that seem to defy explanation, leading some physicists to suggest that particles might be interacting with counterparts in parallel universes. If confirmed, these findings could turn science fiction into science fact, revealing a cosmos far stranger and more expansive than we ever imagined. The implications of a multiverse are as profound as they are mind-bending. Imagine a reality where every decision you've ever made plays out differently in another universe. In one, you might be a world-renowned artist, in another, a pioneering scientist. While this idea might sound like the plot of a blockbuster movie, it raises deep questions about identity, destiny, and the nature of existence. Would knowing that alternate versions of ourselves exist change how we live our lives? Would it make our choices feel more meaningful or less? Beyond the philosophical implications, the multiverse could also revolutionize our understanding of physics. If other universes exist with different physical laws, studying them could help us uncover why our universe is the way it is. Why does gravity follow an inverse square law? Why are there 3 dimensions of space and 1 of time? These questions might find answers in the broader context of the multiverse, offering insights into the very fabric of reality. As we grapple with the idea of infinite universes, another question naturally arises. If our universe is just one of many, what are the chances that life exists elsewhere? This brings us to the next cosmic surprise, one that shifts our gaze from the vastness of the multiverse to the possibility of life beyond our own world. The search for life beyond Earth has long captivated humanity, but what if the answer isn't light years away in some distant star system? What if it's right here in our own cosmic backyard? This brings us to the 4th cosmic surprise, the possibility of alien life lurking in the depths of our solar system, hidden beneath icy moons like Europa and Enceladus. These distant worlds, once thought to be frozen and barren, might hold the key to one of the greatest questions of all: are we alone? Let's start with Europa, one of Jupiter's largest moons. Beneath its icy crust lies a vast subsurface ocean, estimated to contain more than twice the volume of all Earth's oceans combined. This ocean is kept liquid by the gravitational tug of war between Jupiter and its other moons, generating enough heat to prevent the water from freezing solid. Scientists believe this hidden ocean could provide the perfect conditions for life, with hydrothermal vents on the ocean floor potentially serving as hotspots for microbial activity. The chemistry of Europa's ocean even suggests it might contain the essential building blocks of life, such as organic molecules and salts. Enceladus, a small moon orbiting Saturn, offers similar tantalizing possibilities. In 2005, NASA Cassini spacecraft discovered plumes of water vapor and ice erupting from its south pole, revealing the presence of a subsurface ocean. Subsequent observations found that these plumes contain complex organic compounds, including methane and other molecules associated with life as we know it. Enceladus's ocean is also thought to interact with the moon's rocky core, creating a chemical environment that could support microbial life. The discovery of these plumes was a game-changer, as it provided a direct way to sample the moon's ocean without drilling through miles of ice. So, how will we find out if life truly exists on these icy worlds? Enter NASA Europa Clipper, a mission set to launch in the coming years. This spacecraft will conduct detailed reconnaissance of Europa's ice shell and subsurface ocean, mapping its composition and searching for signs of habitability. While the Clipper won't directly search for life, its findings will pave the way for future missions that could land on Europa's surface and drill through the ice to explore the ocean below. Similarly, proposals for missions to Enceladus aim to collect samples from its plumes, analyzing them for biosignatures, chemical traces that could indicate the presence of living organisms. The implications of discovering microbial life on Europa, Enceladus, or elsewhere in our solar system would be nothing short of revolutionary. For starters, it would confirm that life isn't unique to Earth, suggesting that the ingredients and conditions necessary for life might be widespread throughout the universe. This discovery would also challenge our understanding of biology, forcing us to consider how life could arise and thrive in environments vastly different from our own. Imagine a world where life doesn't rely on sunlight, but instead draws energy from chemical reactions deep within an icy ocean. Such a discovery would expand our definition of what life can be and where it can exist. Beyond the scientific implications, finding alien life, even in microbial form, would profoundly shift our perspective on our place in the cosmos. It would remind us that Earth is just one small part of a much larger, interconnected system, sparking new questions about our origins and our destiny. Are we the exception, or are we part of a cosmic norm? And if life can exist in the icy depths of Europa or Enceladus, what other hidden worlds might harbor life waiting to be discovered? As we ponder the possibility of microbial neighbors in our solar system, another question looms even larger. What if we're not the only intelligent beings in the universe? This brings us to the next cosmic surprise: the search for intelligent civilizations beyond Earth. For centuries, humanity has gazed at the stars, wondering if we're alone in the universe. But what if we're closer to an answer than we think? This brings us to the fifth cosmic surprise: the tantalizing possibility of detecting signals from intelligent civilizations beyond Earth. The search for extraterrestrial intelligence, or SETI, isn't just a sci-fi fantasy, it's a scientific endeavor that has already produced some of the most intriguing mysteries in modern astronomy. One of the most famous examples is the WOW signal, a burst of radio waves detected in 1977 by the Big Ear radio telescope in Ohio. Lasting just 72 seconds, this signal was so unusual that the astronomer who discovered it famously wrote "WOW" in the margin of the printout. To this day, the WOW signal remains unexplained, and while it's unlikely to be definitive proof of alien life, it's a powerful reminder that the cosmos might be sending us messages we're only beginning to understand. But the WOW signal is just one piece of the puzzle. Across the globe, radio telescopes are scanning the skies, listening for patterns or anomalies that could indicate intelligent communication. These signals could come in many forms, perhaps a repeating sequence of numbers, a mathematical pattern, or even a deliberate attempt to reach out. The challenge lies in distinguishing these potential messages from natural cosmic noise like pulsars or distant quasars. This is where cutting-edge technology comes into play. Artificial intelligence is revolutionizing the search for extraterrestrial intelligence. With its ability to sift through vast amounts of data at incredible speeds, AI can identify patterns that human researchers might miss. Projects like Breakthrough Listen are already using machine learning to analyze petabytes of radio telescope data, hunting for signs of intelligent life. Future advancements in AI and radio astronomy could bring us closer than ever to decoding a message from the stars. Imagine the moment when a signal is confirmed. What would it say? How would we respond? The discovery of an extraterrestrial signal would be one of the most profound moments in human history. It would challenge our understanding of life, intelligence, and our place in the universe. But it would also raise complex questions. How would humanity react to such a revelation? Would it unite us or create new divisions? Would we attempt to communicate or remain silent out of caution? These are the kinds of questions that keep scientists, philosophers, and dreamers awake at night. As we ponder the possibility of cosmic neighbors, another mystery beckons, one that could change not just how we communicate across the stars, but how we travel through them. This brings us to the next cosmic surprise, the mind-bending concept of wormholes, hypothetical tunnels through space-time that could connect distant parts of the universe or even different universes altogether. What if the vast distances between stars and galaxies weren't as insurmountable as they seem? What if there were cosmic shortcuts, hidden tunnels through the fabric of space-time that could take us from one corner of the universe to another in the blink of an eye? This brings us to the sixth cosmic surprise: wormholes, the theoretical portals that could revolutionize space travel and challenge our understanding of the cosmos. To grasp the idea of a wormhole, picture a piece of paper. If you wanted to travel from one side to the other, you'd normally have to go the long way around. But what if you folded the paper so the 2 points touched, then poked a hole through them? Suddenly, the journey becomes instantaneous. This is the essence of a wormhole, a shortcut through space-time that could connect two distant locations or even different universes in ways that defy our everyday experience of distance and time. The concept of wormholes isn't just science fiction. It emerges from the equations of general relativity, Albert Einstein's groundbreaking theory of gravity. While Einstein himself didn't predict wormholes, later physicists like John Wheeler explored the idea, suggesting these tunnels could exist as solutions to the equations. But here's the catch: wormholes, as we currently understand them, would be incredibly unstable. They'd require exotic forms of matter with negative energy to keep them open, something we've never observed in nature. That hasn't stopped scientists from dreaming, though. Imagine the possibilities if wormholes could be stabilized. A journey to a distant galaxy, which would take millions of years at the speed of light, could become as simple as stepping through a door. Colonies on planets light years away might suddenly be within reach, transforming humanity into a truly interstellar species. The implications for exploration, trade, and even cultural exchange are staggering. We could witness alien sunsets, study civilizations older than our own, and share knowledge with beings from worlds we've yet to imagine. But wormholes aren't just about travel. They could also reshape our understanding of the universe itself. If wormholes exist, they might connect not just distant points in space, but different times, opening the door to the mind-bending possibility of time travel. The idea of visiting the past or future, once confined to the realm of fantasy, could become a scientific reality, raising profound questions about causality and the nature of history. Of course, wormholes remain speculative for now. Detecting or creating one would require breakthroughs in our understanding of quantum gravity, a field that seeks to reconcile general relativity with the strange rules of quantum mechanics. Some theories, like string theory, suggest that wormholes might exist at the tiniest scales, woven into the fabric of spacetime itself. Future experiments with particle accelerators or gravitational wave detectors could provide clues, bringing us closer to unlocking these cosmic shortcuts. As we marvel at the idea of wormholes, another question arises. What if the universe itself is more like a hologram than a three-dimensional space? This leads us to the next cosmic surprise, one that challenges our perception of reality itself. What if everything you see, touch, and experience is nothing more than an elaborate illusion? What if the three-dimensional world we inhabit is just a projection, like a cosmic movie screen, created by information encoded on a two-dimensional surface? This is the seventh cosmic surprise, the holographic universe, a theory so radical it could rewrite the very nature of reality as we know it. The holographic principle, first proposed by physicist Leonard Susskind and later expanded by Gerard T. Hooft, suggests that all the information in our universe, everything from the stars in the sky to the thoughts in your mind, might be stored on a two-dimensional boundary surrounding us. Imagine the universe as a giant hologram where the 3D world we experience is like a projection from this flat surface. It's a mind-bending idea, but one that emerges from the mathematics of black holes and quantum gravity. As Susskind once said, the three-dimensional world of ordinary experience, the universe filled with galaxies, stars, planets, houses, boulders, and people, is a hologram, an image of reality coded on a distant two-dimensional surface. At the heart of this theory is the concept of information. In physics, information is never lost, it's a fundamental law. but when matter falls into a black hole, it seems to disappear, taking its information with it. The holographic principle resolves this paradox by suggesting that the information isn't lost. It's encoded on the black hole's event horizon, the boundary beyond which nothing can escape. This idea has profound implications not just for black holes but for the entire universe. If the information defining our reality is stored on a 2D surface, then everything we perceive, space, time, matter, might be a kind of cosmic illusion, a projection of that data into 3 dimensions. But how could we ever test such a far-out idea? Future experiments in quantum physics might hold the key. Researchers are already exploring ways to detect the pixelation of space-time, the idea that at the smallest scales, space isn't smooth but made up of discrete units like the pixels on a screen. If these experiments reveal evidence of a fundamental limit to how finely we can measure space and time, it could support the holographic principle. Imagine discovering that the universe has a resolution just like a digital image. It would mean that reality itself is finite, quantized, and perhaps even computable. What does this mean for us? If the holographic principle is true, it challenges our most basic assumptions about existence. Are we living in a simulation? Is consciousness itself a product of information encoded on a 2D surface? These questions push the boundaries of science, philosophy, and even spirituality. They force us to reconsider what it means to be real, to exist, and to perceive the world around us. As we grapple with the idea of a holographic universe, another question emerges. If reality is more malleable than we thought, could we one day manipulate it to travel through time? This brings us to the next cosmic surprise, a concept that blurs the line between science and science fiction, the tantalizing possibility of time travel. What if the past and future weren't just places we remember or imagine, but destinations we could visit? This brings us to the 8th cosmic surprise, the tantalizing possibility of time travel through closed time-like curves, a concept rooted in the equations of general relativity. While the idea of hopping into a time machine might seem like pure science fiction, the math behind it is very real, and it suggests that time travel might not be as impossible as we once thought. Closed time-like curves, or CTC, are hypothetical pathways through spacetime that loop back on themselves, allowing an object or even a person to return to its own past. Think of it like walking in a circle, but instead of ending up where you started in space, you end up where you started in time. These curves emerge from Einstein's theory of general relativity, which describes how massive objects warp the fabric of spacetime. Under extreme conditions, like near a rotating black hole or in the presence of exotic matter, spacetime could theoretically twist in such a way that a CTC forms, creating a bridge between different points in time. But before you start planning your trip to the age of dinosaurs, there's a catch. CTCs are incredibly unstable, and their existence would require conditions that push the boundaries of our current understanding of physics. For one, they'd need immense amounts of energy or exotic matter with negative energy density, something we've never observed in nature. Even if we could create or find a CTC, the smallest disturbance could collapse it, making time travel a perilous endeavor. Still, the idea of time travel has captured our imaginations for decades, inspiring countless stories in science fiction. From H.G. Wells' The Time Machine to the iconic Back to the Future films, the concept of traveling through time has been explored in ways that are both thrilling and thought-provoking. These stories often grapple with the grandfather paradox, the idea that changing the past could create contradictions like going back in time and preventing your own birth. But could such paradoxes actually occur, or would the universe find a way to prevent them? Some physicists, like Stephen Hawking, argued that nature has a built-in mechanism to prevent time travel, a concept he called the chronology protection conjecture. Others, like Kip Thorne, have suggested that paradoxes might be resolved through quantum mechanics, where every possible outcome exists in parallel timelines. In this view, altering the past wouldn't erase your future. It would simply create a new one branching off from the original timeline. The ethical implications of time travel are just as fascinating as the science. If we could visit the past, should we? Would changing history lead to unintended consequences, or could it be used to prevent tragedies? And what about the future? Would knowing what's to come rob us of our free will? These questions don't just belong to philosophers, they're deeply intertwined with the science of time travel itself. While we're not likely to see a working time machine anytime soon, the study of CTCs could still revolutionize our understanding of physics. Future advancements in quantum gravity or experiments with high-energy particles might reveal new insights into how space-time behaves under extreme conditions. Even if time travel remains confined to the microscopic realm, the implications would be profound, challenging our notions of causality, reality, and the very nature of time itself. As we ponder the mysteries of time travel, another cosmic enigma awaits, one that's as mysterious as it is mesmerizing. What if the key to understanding the universe lies not in the stars, but in the darkest corners of space, where gravity is so intense that even light can't escape? This brings us to the next cosmic surprise, the enigmatic nature of black holes. Black holes have long been the ultimate cosmic enigmas, regions of space where gravity is so intense that nothing, not even light, can escape. But what if these cosmic vacuums aren't just destructive forces? What if they're gateways to other universes, dimensions, or even entirely new realities? This brings us to the ninth cosmic surprise, the tantalizing idea that black holes might be more than just gravitational traps. They could be portals to the unknown. To understand how black holes could serve as gateways, let's start with what we know. At the heart of every black hole lies a singularity, a point where matter is crushed to infinite density and the laws of physics as we know them break down. Surrounding the singularity is the event horizon, the boundary beyond which nothing can escape. Think of the event horizon like the edge of a waterfall. Once you cross it, there's no turning back. You're pulled inexorably toward the singularity. But what happens at the singularity? Some theories suggest it might not be the end of the road. Instead, it could be a bridge to another place entirely. One of the most intriguing possibilities is that black holes could connect to other universes or dimensions through structures known as wormholes. These hypothetical tunnels, often called Einstein-Rosen bridges, emerge from the equations of general relativity. While they're still speculative, the idea is that a black hole in our universe might link to a white hole in another, a region where matter and energy are expelled rather than consumed. It's like a cosmic escape hatch offering a potential route to another reality. Recent discoveries have brought us closer than ever to understanding these mysterious objects. In 2019, the Event Horizon Telescope collaboration unveiled the first ever image of a black hole, capturing the shadow of the supermassive black hole at the center of the galaxy M87. This groundbreaking achievement not only confirmed the existence of black holes, but also provided a glimpse of their structure, including the glowing ring of light around the event horizon. Future observations using more advanced telescopes and gravitational wave detectors could reveal even more about what lies beyond the event horizon, perhaps even evidence of wormholes or other exotic phenomena. But black holes aren't just gateways to other places, they're also windows into the fundamental nature of reality. The extreme conditions near a black hole's singularity push the limits of our understanding of physics, forcing us to reconcile general relativity with quantum mechanics. Some theories, like loop quantum gravity, suggest that singularities might not be points of infinite density, but rather regions where space-time is woven into a quantum fabric. If true, this could mean that black holes don't destroy information but instead transform it, potentially encoding it on the event horizon in what's known as the holographic principle. The idea of black holes as gateways is both thrilling and humbling. It reminds us that the universe is far stranger and more interconnected than we ever imagined. But as we peer into the abyss of these cosmic mysteries, another question emerges. What if the universe itself is part of an even grander cycle, one where black holes play a key role? This leads us to the next cosmic surprise, a theory that suggests our universe might not be the first or the last in an endless cycle of birth, death, and rebirth. What if the Big Bang wasn't the beginning of everything but just one chapter in an endless cosmic story? What if the universe has been expanding and contracting in an eternal dance, with each cycle giving birth to a new cosmos? This brings us to the 10th cosmic surprise, the Cyclic Universe Theory, a mind-bending idea that challenges our understanding of the Big Bang and the ultimate fate of everything we know. The cyclic model proposes that the universe doesn't have a single beginning or end. Instead, it undergoes an infinite series of expansions and contractions, like the inhale and exhale of a cosmic breath. In this view, the Big Bang wasn't a unique event but rather the start of the latest cycle. After expanding for billions of years, the universe could eventually slow down, reverse direction, and collapse back into a dense state only to explode outward again in a new Big Bang. It's a vision of the cosmos that replaces a one-time creation with an eternal rhythm, a never-ending loop of birth, death, and rebirth. But how could we ever test such a profound idea? The answer might lie in the faint afterglow of the Big Bang itself, the cosmic microwave background radiation, or CMB. This ancient light which fills the universe is like a snapshot of the early cosmos, and it holds clues to its history. Future observations of the CMB, particularly its subtle patterns and anomalies, could reveal evidence of past cycles. For example, if the universe has undergone multiple expansions and contractions, there might be faint imprints in the CMB from earlier cycles, like cosmic echoes reverberating through time. Projects like the European Space Agency's Planck satellite and future missions are already mapping the CMB in unprecedented detail, searching for these elusive signatures. The implications of a cyclic universe are staggering. It would mean that the Big Bang wasn't the ultimate beginning but just one event in an infinite sequence. It would also challenge our understanding of time itself. If the universe has no true start or end, then time might not be linear but cyclical, looping back on itself in ways that defy our everyday experience. This raises profound questions about the nature of infinity. Could there have been an infinite number of universes before ours, and if so, what does that mean for the concept of existence? The cyclic model also offers a new perspective on the ultimate fate of the universe. Instead of ending in a cold, dark expanse as predicted by the Big Freeze or collapsing into a big crunch, the universe might simply reset, starting the cycle anew. This idea brings a sense of poetic symmetry to the cosmos, suggesting that destruction and creation are intertwined in an eternal dance. It's a vision that's both humbling and awe-inspiring, reminding us that the universe is far more dynamic and interconnected than we often imagine. As we contemplate the possibility of an endless cycle of universes, another question emerges. What drives the universe to expand in the first place? This leads us to the next cosmic surprise, one that explores the mysterious force shaping the fate of the cosmos' dark energy. What if the universe is being stretched apart by an invisible force, one that's silently shaping the fate of everything we know? This brings us to the 11th cosmic surprise, the enigmatic force known as dark energy, a mysterious power that's not only driving the expansion of the universe but accelerating it. It's a discovery that has left scientists both astonished and puzzled. reshaping our understanding of the cosmos and its ultimate destiny. In the late 1990s, astronomers made a startling observation. By studying distant supernova, they found that the universe wasn't just expanding, it was doing so at an ever-increasing rate. This was a shock, as most scientists had assumed that gravity, the force pulling everything together, would eventually slow the expansion. Instead, something else was at work, pushing galaxies apart faster and faster. This something was dubbed dark energy, and it's now believed to make up nearly 70% of the universe's total energy. Yet, despite its overwhelming presence, we still don't know what it is. One leading theory suggests that dark energy could be a property of space itself, often referred to as the cosmological constant. Proposed by Albert Einstein over a century ago, the cosmological constant was originally introduced as a way to balance the equations of general relativity, ensuring a static universe. When Einstein learned that the universe was expanding, he famously called it his greatest blunder. But now it seems he might have been onto something. If dark energy is indeed a property of space, it would mean that empty space isn't truly empty. It's filled with a kind of energy that grows stronger as the universe expands. Another possibility is that dark energy is a new kind of force field, something entirely distinct from anything we've encountered before. Some physicists have even speculated that it could be related to the quantum fluctuations of the vacuum, the same fluctuations that give rise to particles popping in and out of existence. If true, this would mean that dark energy is woven into the very fabric of reality, a fundamental force that's been there since the beginning. So how will we ever solve this cosmic riddle? Enter the James Webb Space Telescope, one of the most advanced observatories ever built. With its unprecedented ability to peer into the distant universe, Webb is already providing new insights into the nature of dark energy. By studying the light from ancient galaxies and supernova, scientists hope to measure the rate of cosmic expansion with greater precision than ever before. These observations could reveal whether dark energy has remained constant over time or if it's changing, a clue that might help us understand its true nature. The implications of dark energy are as profound as they are unsettling. If the universe continues to expand at an accelerating rate, galaxies will eventually drift so far apart that they'll become invisible to one another. Stars will burn out and the cosmos will grow cold and dark, a scenario known as the Big Freeze. On the other hand, if dark energy behaves in unexpected ways, it could lead to a big rip, tearing apart galaxies, planets, and even atoms. Or perhaps dark energy could weaken over time, allowing gravity to pull everything back together in a big crunch. The fate of the universe hinges on this mysterious force, and unlocking its secrets could reveal whether we're headed toward an eternal expansion, a fiery collapse, or something entirely unexpected. As we grapple with the mysteries of dark energy, another tantalizing idea emerges, one that shifts our gaze from the vast expanse of the cosmos to the inner workings of the mind. What if the universe isn't just a collection of stars and galaxies, but a network of consciousness, a cosmic web that connects all living beings? This brings us to the next cosmic surprise, a concept that blurs the line between science and philosophy, the possibility of a universal consciousness. What if consciousness isn't just a product of the brain, but a fundamental feature of the universe itself? What if every star, every planet, and even the fabric of space-time itself holds a spark of awareness, woven together into a vast, interconnected cosmic web? This brings us to the 12th cosmic surprise, the idea that consciousness might be as intrinsic to the universe as gravity or light, a force that binds all things together in ways we're only beginning to understand. The concept of a universal consciousness isn't new. Philosophers and mystics have pondered it for centuries, but now some scientists are taking it seriously. One of the leading theories in this realm is panpsychism, the idea that consciousness is a fundamental property of matter, much like mass or charge. According to this view, even the smallest particles might possess a rudimentary form of awareness. When these particles come together in complex systems like the human brain, they give rise to the rich, self-reflective consciousness we experience. But panpsychism goes further, suggesting that the entire universe could be alive with awareness from the tiniest quark to the largest galaxy. While this might sound like science fiction, there are intriguing reasons to consider it. Quantum physics, for example, has long hinted at the strange, interconnected nature of reality. Experiments have shown that particles can become entangled, meaning their properties are linked even across vast distances. Some researchers have speculated that this quantum interconnectedness could be a physical manifestation of a deeper, universal consciousness, a cosmic web that ties everything together. Imagine the universe not as a collection of separate objects, but as a single, unified entity pulsing with awareness. Neuroscience is also shedding light on the nature of consciousness. Studies on how the brain generates subjective experience have revealed that consciousness isn't confined to a single region, but emerges from the complex interactions of billions of neurons. This has led some scientists to propose that consciousness might be a universal phenomenon, arising whenever information is processed in a certain way. If true, this would mean that consciousness isn't unique to humans or even Earth. It could be a fundamental aspect of reality, present wherever the right conditions exist. So, what would it mean if consciousness truly is woven into the fabric of the universe? For one, it could reshape our understanding of life itself. If even inanimate objects possess a degree of awareness, then the line between living and non-living becomes blurred, and the universe transforms from a cold, mechanical place into a vibrant, interconnected whole. It could also have profound implications for how we see ourselves and our place in the cosmos. Are we isolated observers, or are we part of a vast, conscious network, each of us a thread in the cosmic tapestry? This idea also raises profound questions about the nature of reality. If consciousness is fundamental, does that mean the universe is, in some sense, aware of itself? Could the cosmos be a kind of living entity, evolving and learning over time? And if so, what role do we play in its unfolding story? These are the kinds of questions that push the boundaries of science, philosophy, and spirituality, inviting us to see the universe not as a collection of objects, but as a dynamic, conscious process. As we ponder the possibility of a universal consciousness, another tantalizing idea emerges, one that takes the concept of interconnectedness to an even more mind-bending level. What if the universe itself is a simulation, a vast, intricate program running on some cosmic computer? This brings us to the next cosmic surprise, the simulation hypothesis, a theory that suggests our reality might be nothing more than a digital construct. What if everything you've ever known, every sight, sound, and sensation was nothing more than lines of code in a cosmic computer program? This is the 13th cosmic surprise, the simulation hypothesis, a theory that suggests our reality might not be real at all, but an artificial construct created by an advanced civilization. It's a concept that sounds like something straight out of a sci-fi movie, but believe it or not, it's a serious idea that philosophers, scientists, and even tech billionaires are taking seriously. The simulation hypothesis was popularized by philosopher Nick Bostrom in 2003, who argued that one of three possibilities must be true. Either advanced civilizations never reach the level of technology needed to create simulations of reality, they choose not to create them, or we are almost certainly living in one. Bostrom's reasoning is based on probability. If civilizations can eventually create simulations indistinguishable from reality, and if they have the desire to run countless such simulations, then the odds are overwhelming that we're in one of those simulations rather than the original, base reality. But how could we ever test such a mind-bending idea? One approach comes from physics. Researchers have speculated that if our universe is a simulation, it might have a resolution limit, much like a video game. At extremely small scales, spacetime might not be smooth but pixelated, made up of tiny, discrete units. Some physicists are already searching for these telltale signs in cosmic rays and particle collisions. If they find evidence of a fundamental grid underlying reality, it could be a clue that we're living in a digital construct. Another way to explore the simulation hypothesis is through computing. As our own technology advances, we're getting closer to creating realistic virtual worlds. Imagine a future where entire civilizations could be simulated with perfect accuracy, complete with conscious beings who believe they're real. If this becomes possible, it raises the question, how do we know we're not already in such a simulation? Elon Musk famously quipped, "The odds that we're in base reality is 1 in billions," highlighting just how plausible this idea has become. The implications of the simulation hypothesis are staggering. If true, it would mean that everything we perceive, our memories, relationships, even our sense of self, could be artificial constructs. It challenges our understanding of free will. Are our choices truly ours, or are they predetermined by the code running the simulation? And what about morality? If our actions don't have real-world consequences, does it matter how we behave? These questions don't just belong to philosophers, they force us to rethink the very nature of existence. But let's take a step back. Even if we're living in a simulation, does it change anything? After all, our experiences still feel real to us. Pain, joy, love, these emotions are no less vivid if they're the product of code. In some ways, the simulation hypothesis might even deepen our appreciation for life, reminding us to cherish every moment, whether it's real or not. As we grapple with the possibility that our reality might be a simulation, another question arises: what if death itself is an illusion? This brings us to the next cosmic surprise, a concept that pushes the boundaries of science and philosophy even further: the idea of quantum immortality. What if death isn't the end, but merely a transition? What if every time you face a life-threatening situation, your consciousness shifts to a parallel universe where you survive? This is the 14th cosmic surprise, the mind-bending concept of quantum immortality, a theory that suggests consciousness might never truly end but instead continues in alternate realities, forever branching into new possibilities. To understand this idea, let's start with a famous thought experiment, Schrödinger's cat. In this scenario, a cat is placed in a sealed box with a device that has a 50% chance of killing it. According to quantum mechanics, until the box is opened, the cat exists in a superposition, simultaneously alive and dead. It's only when we observe the system that the outcome becomes definite. But what if this principle applies to us? What if every time you face a life or death situation, the universe splits into two, one where you survive and one where you don't? From your perspective, you'd always find yourself in the reality where you live, no matter how improbable the odds. This idea, known as quantum immortality, emerges from the many worlds interpretation of quantum mechanics. In this view, every possible outcome of a quantum event creates a new universe. If you're in a car accident, for example, there's a universe where you walk away unscathed and another where you don't. But because you can only experience the reality where you survive, your consciousness would always land in the universe where you're alive. It's a strange and unsettling thought, but one that challenges our deepest assumptions about life, death, and identity. So how could we ever test such a theory? While quantum immortality remains speculative, future advancements in quantum mechanics might provide clues. For instance, experiments with quantum entanglement, where particles remain connected across vast distances, could reveal more about how consciousness interacts with the quantum realm. Some researchers have even suggested that consciousness itself might play a role in collapsing quantum superpositions, a hypothesis that blurs the line between observer and observed. But quantum immortality isn't just a scientific curiosity. It raises profound questions about existence. If consciousness persists across parallel universes, does that mean we're immortal in some sense? And what does it mean for our sense of self? Are we the same person in every universe, or do we fragment into countless versions of ourselves, each living a slightly different life? These questions push the boundaries of philosophy, forcing us to rethink what it means to be alive, or even to be at all. The idea of quantum immortality also challenges our notions of fate and free will. If every decision creates a new universe, are we truly making choices, or are we simply riding the wave of infinite possibilities? And if so, does that mean every version of us is equally real? Or is there something special about the us we experience right now? These are the kinds of questions that keep scientists and philosophers awake at night, pondering the nature of existence itself. As we reflect on the possibility of parallel selves and quantum immortality, another question arises. What if consciousness isn't just a personal experience but a universal phenomenon, woven into the very fabric of reality? This leads us to the next cosmic surprise, a concept that takes the idea of interconnectedness to an even deeper level, the potential for a cosmic consciousness. What if the universe isn't just a sprawling expanse of stars and galaxies, but a living, evolving entity slowly awakening to its own existence? What if the ultimate destiny of the cosmos isn't just the birth and death of stars, but the emergence of a shared, collective consciousness that spans across space and time? This brings us to the 15th cosmic surprise, the tantalizing possibility that the universe itself might be evolving toward a state of cosmic consciousness, a unified awareness that connects all things from the tiniest particles to the largest galaxies. At first glance, this idea might sound like something out of a sci-fi novel, but it's rooted in a fascinating intersection of science and philosophy. Just as life on Earth evolved from single-celled organisms to complex, self-aware beings, some thinkers suggest that the universe itself could be on a similar trajectory. This concept, often referred to as the omega point theory, was popularized by philosopher Pierre Teilhard de Chardin, who envisioned a future where the cosmos reaches a state of maximum complexity and consciousness. In this view, humanity isn't just a passive observer of the universe, but an active participant in its evolution, playing a crucial role in this grand awakening. But how could such a cosmic consciousness emerge? One possibility lies in the rapid advancements of artificial intelligence and neuroscience. Imagine a future where AI systems become so advanced that they merge with human minds, creating a vast network of interconnected intelligences. These networks could grow to encompass entire civilizations, forming a kind of global brain that processes information on a scale we can barely comprehend. Over time, this network might expand further, connecting not just minds on Earth but potentially across the universe, weaving together a tapestry of awareness that spans galaxies. Neuroscience also offers intriguing clues. Studies on how the brain generates consciousness have revealed that it's not just the individual neurons that matter, but the complex patterns of connections between them. Some researchers have speculated that the universe might operate in a similar way, with the intricate web of galaxies, dark matter, and quantum fields acting like a cosmic brain. If that's the case, then the universe itself could already be a kind of conscious entity, slowly becoming aware of itself as it evolves. The implications of a cosmic consciousness are profound. For one, it would redefine humanity's role in the cosmos. Instead of being mere inhabitants of the universe, we might be essential players in its unfolding story, helping to shape its future and bring about its ultimate realization. It also raises deep questions about the nature of intelligence and evolution. Are we just one step in a much larger process, destined to be surpassed by even greater forms of awareness? Or are we the catalysts for a new era of cosmic enlightenment, where the universe itself becomes sentient? These questions don't just belong to scientists and philosophers. They invite all of us to reflect on our place in the grand scheme of things. If the universe is evolving toward a state of collective consciousness, what does that mean for how we live our lives? Should we strive to connect more deeply with one another, fostering the kind of unity that might one day encompass the cosmos? And if the universe is, in some sense, alive, how should we treat it not just as a resource to be exploited, but as a partner in our shared journey? As we contemplate the possibility of a cosmic consciousness, another question arises. What if the universe isn't just a single, unified entity, but a complex tapestry woven from multiple dimensions, each with its own set of physical laws? This leads us to the next cosmic surprise, a concept that stretches the boundaries of reality even further, the idea of a multidimensional universe. What if the world we see, with its length, width, and depth, is just a fraction of what truly exists? What if there are hidden dimensions, curled up so tightly or stretched so far that we can't perceive them? This brings us to the 16th cosmic surprise, the tantalizing possibility of extra dimensions beyond the three we experience every day. These unseen layers of reality could be the key to unlocking some of the universe's deepest mysteries, and they might be hiding in plain sight. The idea of extra dimensions isn't just science fiction. It's rooted in one of the most ambitious theories in modern physics, string theory. According to this framework, the fundamental building blocks of the universe aren't particles but tiny, vibrating strings. For the math to work, these strings need more room to move than the three dimensions we're familiar with. In fact, string theory suggests there could be up to 10 or even 11 dimensions, all folded into the fabric of reality. Some of these dimensions might be so small, curled up like the fibers of a rug, that they're invisible to us, while others could be vast, stretching far beyond our observable universe. To grasp this mind-bending concept, let's turn to a classic analogy, flatland. Imagine a two-dimensional world like a sheet of paper where beings can only move forward, backward, left, and right. They have no concept of up or down because those directions don't exist in their reality. Now, picture a three-dimensional object like a sphere passing through flatland. To the flatlanders, the sphere would appear as a series of circles growing and shrinking, completely incomprehensible as a whole. In the same way, if there are higher dimensions beyond our perception, we might only catch fleeting glimpses of them like shadows on a wall, without ever fully understanding their true nature. So, how could we ever detect these hidden dimensions? The answer might lie in particle physics. Experiments at facilities like the Large Hadron Collider are probing the subatomic world, searching for clues that could hint at extra dimensions. One possibility is that certain particles, like gravitons, might leak into these dimensions, explaining why gravity is so much weaker than the other fundamental forces. If scientists can find evidence of such particles or observe anomalies in particle collisions, it could be the smoking gun for extra dimensions. Future advancements in technology, like more powerful particle accelerators or gravitational wave detectors, might bring us closer to this groundbreaking discovery. But what would it mean if we found proof of extra dimensions? For one, it could revolutionize our understanding of the universe, providing answers to questions that have puzzled scientists for decades. Why is gravity so weak compared to electromagnetism or the strong nuclear force? What lies beyond the event horizon of a black hole? These mysteries might find solutions in the hidden folds of space-time. Moreover, extra dimensions could open the door to entirely new realms of physics, revealing forces, particles, and phenomena we've never imagined. It's like discovering a hidden room in a house you've lived in your entire life. Suddenly, the possibilities are endless. As we contemplate the idea of hidden dimensions, another question naturally arises. What if the universe itself had no beginning? What if the Big Bang wasn't the start of everything, but just one event in an infinite cycle? This leads us to the next cosmic surprise, a concept that challenges our understanding of time and existence, the possibility of a universe with no beginning. What if the universe didn't have a beginning at all? What if the Big Bang, the event we've long considered the starting point of everything, was just one moment in an endless cycle of cosmic rebirth? This brings us to the 17th cosmic surprise, the possibility that the universe might not have had a singular beginning, but instead exists in a state of eternal existence, one where time itself has no starting point. This idea might sound like a paradox, but it's rooted in some of the most cutting-edge theories in physics. One such theory is the no-boundary proposal, put forward by physicists Stephen Hawking and James Hartle. According to this model, the universe doesn't have a sharp, well-defined beginning like the Big Bang suggests. Instead, time behaves more like a sphere with no edges or boundaries. Picture the Earth. You can travel around it endlessly without ever reaching a starting point. In the no-boundary universe, time works in a similar way, looping back on itself in a seamless, infinite cycle. It's a concept that redefines not just how we think about the Big Bang, but how we understand the very nature of time. But how could we ever test such an extraordinary idea? The answer might lie in the cosmic microwave background, or CMB, the faint afterglow of the Big Bang that still permeates the universe. This ancient light holds a treasure trove of information about the early cosmos, and future observations of its subtle patterns could provide clues about the universe's true origins. For example, if the no-boundary proposal is correct, the CMB might reveal certain anomalies or asymmetries that hint at a universe without a singular beginning. Projects like the European Space Agency's Planck satellite are already mapping the CMB in unprecedented detail, and upcoming missions could bring us even closer to answering this profound question. The implications of a universe without a beginning are staggering. For one, it would challenge our understanding of creation itself. If the universe has always existed in some form or another, then the Big Bang becomes less of a starting point and more of a transition, a moment of transformation rather than an absolute beginning. It also raises deep questions about the nature of time. Is time linear as we experience it, or is it cyclical, looping endlessly without a true start or finish? And if time has no beginning, what does that mean for the concept of infinity? Are we part of an endless cosmic dance, one that has no origin and no end? This idea also invites us to reconsider our place in the cosmos. If the universe has always existed, then our existence isn't just a fleeting moment in time. It's part of an eternal process, one that stretches infinitely into the past and future. It's a perspective that's both humbling and awe-inspiring, reminding us that the universe is far more mysterious and interconnected than we often realize. As we ponder the possibility of a universe without a beginning, another question naturally arises. What if time itself isn't as straightforward as we think? What if the past, present, and future aren't just points on a line, but branches on a tree, each leading to a different version of reality? This leads us to the next cosmic surprise, a concept that takes the idea of multiple timelines to a whole new level. What if every decision you've ever made, every choice, big or small, created a new universe, branching off into an infinite web of alternate realities? This brings us to the 18th cosmic surprise, the mind-bending idea of multiple timelines and alternate histories, a concept that suggests our reality is just one thread in an endlessly complex cosmic tapestry. According to the many worlds interpretation of quantum mechanics, every possible outcome of every event actually happens, each playing out in its own separate universe. It's a theory that challenges not just our understanding of reality, but the very nature of choice, destiny, and identity. To grasp this idea, let's revisit a classic quantum experiment, Schrödinger's cat. In this thought experiment, a cat is placed in a sealed box with a device that has a 50% chance of killing it. According to quantum mechanics, until the box is opened, the cat exists in a superposition, simultaneously alive and dead. But the many worlds interpretation takes this a step further. Instead of the superposition collapsing into a single outcome when observed, it suggests that both outcomes occur, each in its own separate universe. In one timeline, the cat lives, in another, it doesn't. And this branching isn't limited to cats in boxes, it applies to every decision, every event, everywhere in the universe. Science fiction has long played with this concept, offering vivid portrayals of alternate realities. Take the iconic Back to the Future series, where Marty McFly's actions in the past create entirely new timelines, altering the future in ways he never anticipated. Or consider Marvel's What If series, which explores how small changes could lead to drastically different outcomes. These stories aren't just entertaining, they reflect a deep human fascination with the idea that our choices matter, that every decision sends ripples across the fabric of reality. But what if this isn't just fiction? What if the many worlds interpretation is correct and every decision you make spawns a new universe? This raises profound questions about free will and destiny. If every possible outcome exists somewhere, does that mean our choices are meaningless since every version of us is playing out every option? Or does it make our decisions even more significant, knowing that each one creates a new reality? These are the kinds of questions that blur the line between science and philosophy, inviting us to rethink what it means to live a meaningful life. So, how could we ever test such a radical idea? Future advancements in quantum physics might hold the key. For instance, experiments with quantum entanglement, where particles remain connected across vast distances, could reveal more about how the universe chooses between possible outcomes. Some researchers are even exploring whether consciousness plays a role in collapsing quantum superpositions, a hypothesis that could deepen our understanding of how observers shape reality. While definitive proof remains elusive, the pursuit of these questions is pushing the boundaries of both science and imagination. The implications of multiple timelines are staggering. If every decision creates a new universe, then the cosmos is far more dynamic and interconnected than we ever imagined. It also raises questions about identity. Are we the same person in every timeline, or do we fragment into countless versions of ourselves, each living a slightly different life? And if so, does that mean there's a version of us out there who made all the right choices, living the perfect life we've always dreamed of? These questions don't just belong to physicists, they're deeply personal, inviting us to reflect on our own lives and the paths we've chosen. As we ponder the infinite possibilities of multiple timelines, another question emerges. What if the universe itself has no end? What if, instead of fading into darkness, the cosmos undergoes an eternal cycle of renewal, forever expanding and contracting in an endless cosmic dance? This leads us to the next cosmic surprise, a concept that challenges our understanding of time, existence, and the ultimate fate of everything we know. What if the universe doesn't have an ending? What if, instead of fading into darkness or collapsing into a fiery crunch, it continues to expand and evolve forever, stretching into an infinite future? This brings us to the 19th cosmic surprise, the possibility that the universe might be eternal with no definitive end. It's a concept that challenges our understanding of time, existence, and the ultimate destiny of everything we know. The idea of an eternal universe isn't just philosophical, it's grounded in some of the most cutting-edge theories in cosmology. One key piece of this puzzle is dark energy, the mysterious force driving the accelerated expansion of the universe. If dark energy continues to dominate, as current observations suggest, the cosmos could keep expanding indefinitely. Galaxies would drift farther apart, stars would burn out, and the universe would grow colder and darker over trillions of years, a scenario known as the Big Freeze. But unlike the dramatic collapse of a big crunch or the violent rip of a big rip, this fate is slow and quiet, a gradual fading rather than a definitive end. But what if this expansion isn't the final chapter? Some theories propose that the universe could cycle through phases of expansion and contraction, endlessly renewing itself. In this view, the Big Bang wasn't a one-time event but part of an eternal rhythm, like the inhale and exhale of a cosmic breath. Each cycle begins with a burst of energy and ends with a collapse only to start anew. It's a vision of the cosmos that replaces a linear timeline with an infinite loop, a never-ending story of creation and destruction. So, how could we ever test such an extraordinary idea? The answer might lie in the faint echoes of the Big Bang itself. The cosmic microwave background, or CMB, is a treasure trove of information about the early universe, and future observations could reveal clues about its ultimate fate. For instance, subtle patterns or asymmetries in the CMB might hint at past cycles or the presence of exotic particles that could sustain an eternal universe. Projects like the James Webb Space Telescope and next-generation gravitational wave detectors are already pushing the boundaries of what we can observe, bringing us closer to answering these profound questions. The implications of an eternal universe are staggering. For one, it challenges our understanding of time itself. If the cosmos has no end, does that mean time is infinite? And if so, what does that mean for the concept of existence? Are we part of an eternal process, one that stretches infinitely into the future? It also raises deep questions about the nature of infinity. Can something truly be endless, or is eternity just another illusion, a way for our minds to grasp the ungraspable? This idea also invites us to reconsider our place in the cosmos. If the universe is eternal, then our existence isn't just a fleeting moment, it's part of an infinite tapestry, woven into the fabric of reality itself. It's a perspective that's both humbling and awe-inspiring, reminding us that the universe is far more mysterious and interconnected than we often realize. As we ponder the possibility of an eternal universe, another question arises. What if our reality is just one of many? What if the cosmos isn't a single, unified entity, but a patchwork of countless universes, each with its own set of physical laws and histories? This leads us to the next cosmic surprise, a concept that takes the idea of infinity to an even more mind-bending level, the multiverse. What if every decision you've ever made, every choice, every path not taken exists somewhere in an infinite sea of realities? What if there's a version of you reading this in a universe where dinosaurs never went extinct, where humanity discovered warp drive centuries ago, or where the laws of physics themselves are entirely different? This brings us to the 20th cosmic surprise, the multiverse of realities, a mind-bending theory that suggests every possible outcome, every alternate history, and every conceivable version of existence is playing out somewhere in an endless array of parallel universes. It's a concept that stretches the boundaries of imagination, challenging not just our understanding of the cosmos, but the very nature of reality itself. The multiverse theory isn't just a single idea, it's a tapestry of interconnected hypotheses. each offering a unique perspective on how multiple universes could exist. One of the most compelling versions comes from quantum mechanics, specifically the many worlds interpretation. According to this theory, every time a quantum event occurs, like the decay of a radioactive atom or the spin of an electron, the universe splits into multiple branches, each representing a different outcome. In one universe, the atom decays; in another, it doesn't. Over time, these branching paths create an infinite web of realities, each slightly or drastically different from our own. But quantum mechanics isn't the only field pointing to a multiverse. Cosmology offers its own tantalizing clues. The concept of cosmic inflation, which describes the rapid expansion of the universe just after the Big Bang, suggests that our universe might be just one bubble in a vast cosmic foam. Each bubble could have its own set of physical laws, its own history, and its own version of reality. Some might be unimaginably strange, with dimensions we can't perceive or forces we've never encountered. Others might be eerily similar to our own, with slight variations, like a universe where you chose a different career or where humanity evolved on a different planet. To grasp the sheer scale of the multiverse, imagine a library so vast that it contains every book ever written and every book that could ever be written. Now imagine that each book is a universe with its own story, its own rules, and its own characters. The multiverse is like that library, but infinitely larger, containing not just every possible story, but every possible variation of every story. It's a concept that's as awe-inspiring as it is humbling, reminding us that our reality might be just one page in an infinitely complex cosmic narrative. So, how could we ever find evidence for something so extraordinary? Future breakthroughs in quantum physics and cosmology might hold the key. For instance, experiments with quantum entanglement, where particles remain connected across vast distances, could reveal subtle anomalies that hint at interactions with other universes. Similarly, observations of the cosmic microwave background, the faint afterglow of the Big Bang, might uncover patterns or imprints left by collisions between our universe and others. Projects like the James Webb Space Telescope and next-generation particle accelerators are already pushing the boundaries of what we can observe, bringing us closer to unlocking these cosmic secrets. But the multiverse isn't just a scientific curiosity, it's a profound philosophical challenge. If every possible reality exists, what does that mean for our sense of identity? Are we the same person in every universe, or do we fragment into countless versions of ourselves, each living a different life? And if so, does that make our choices more meaningful or less? These questions don't just belong to physicists, they invite all of us to reflect on our place in the cosmos and the nature of existence itself. As we grapple with the infinite possibilities of the multiverse, another question emerges. What if the laws of physics aren't universal? What if, somewhere in the cosmic tapestry, there's a universe where the rules we take for granted, gravity, electromagnetism, even time itself, don't apply? This leads us to the next cosmic surprise, a concept that challenges everything we thought we knew about the fabric of reality. What if the very rules that govern the cosmos, gravity, electromagnetism, even the speed of light, aren't as universal as we think? What if somewhere out there the laws of physics themselves bend, shift, or even break? This brings us to the 21st cosmic surprise, the tantalizing possibility that the laws of physics might not be fixed across the universe. It's an idea that challenges the foundation of science itself, suggesting that what we consider absolute truths could be more like local customs, varying from place to place in the vast expanse of space. For centuries, scientists have operated under the assumption that the laws of physics are uniform everywhere. The speed of light in a vacuum, the gravitational constant, the charge of an electron, these are the building blocks of our understanding of the universe. But what if these constants aren't so constant after all? Recent observations have sparked a radical hypothesis that the fundamental laws of nature might change over time or vary across different regions of the cosmos. This idea, known as the varying constants hypothesis, could upend everything we thought we knew about reality. One area where this hypothesis has gained traction is in the study of distant galaxies. By analyzing the light from quasars, extremely bright objects powered by supermassive black holes, scientists have detected subtle variations in the fine structure constant, a number that governs the strength of electromagnetic interactions. In some regions of the universe, this constant appears to be slightly different, suggesting that the laws of physics might not be as universal as we once believed. If confirmed, this discovery would be a game-changer, forcing us to rethink not just the nature of the cosmos, but the very principles that guide our exploration of it. So, how could we ever test such a radical idea? Future observatories, like the extremely large telescope currently under construction in Chile, could provide the answers. By studying the light from even more distant galaxies, scientists hope to map these potential variations across the universe, creating a kind of cosmic rulebook that shows how the laws of physics might change over space and time. These observations could also reveal whether these variations follow a pattern or are random, offering clues about the underlying mechanisms at work. The implications of this discovery are profound. If the laws of physics aren't fixed, then the universe becomes far more dynamic and unpredictable than we ever imagined. It could mean that life, as we know it, might only be possible in regions where the constants align just right, making our existence a cosmic coincidence. It also raises deep questions about the nature of scientific truth. Are the laws of physics absolute, or are they simply the best description we have of the world around us? And if they can change, what does that mean for our understanding of reality? This idea also invites us to reflect on the nature of exploration itself. If the laws of physics vary across the universe, then every new discovery could reveal a completely different set of rules, challenging us to adapt and rethink our approach. It's a reminder that science is not a static collection of facts, but a living, evolving process, one that constantly pushes us to question, explore, and imagine. As we grapple with the possibility of a universe without fixed laws, another question naturally arises. What if the cosmos itself has no boundaries? What if the universe is infinite, stretching endlessly in all directions, with no edge, no center, and no end? This leads us to the next cosmic surprise, a concept that challenges our understanding of space, time, and the very nature of existence. What if the universe isn't just vast, but truly limitless? What if there's no edge, no center, and no boundary to the cosmos, just an endless expanse stretching infinitely in every direction? This brings us to the 22nd cosmic surprise, the possibility that the universe is infinite and unbounded, a concept that challenges our deepest assumptions about space, time, and the very nature of existence. It's an idea that stretches the imagination, inviting us to consider a reality where the cosmos has no end, and perhaps no beginning either. The notion of an infinite universe isn't just a philosophical musing, it's grounded in some of the most compelling theories in cosmology. For centuries, humans have grappled with the idea of infinity, often struggling to wrap their minds around something so vast and unknowable. Yet modern science suggests that the universe might indeed be infinite, with no boundaries to contain it. How could we ever test such an extraordinary claim? The answer lies in the faint echoes of the Big Bang itself, the cosmic microwave background radiation. The cosmic microwave background, or CMB, is the oldest light in the universe, a relic from the moment the cosmos became transparent to light, just 380,000 years after the Big Bang. This ancient glow fills the sky, carrying with it subtle patterns and clues about the universe's origins and structure. By studying these patterns, scientists can infer whether the universe is finite or infinite. For instance, if the universe were finite, the patterns in the CMB would eventually repeat like images in a hall of mirrors. But if the universe is infinite, the patterns would be unique and unrepeating, stretching endlessly in every direction. So far, observations of the CMB suggest that the universe is flat, meaning that space isn't curved back on itself but extends infinitely in all directions. This flatness is a key indicator of an infinite universe. Future missions like the European Space Agency's Planck satellite and next-generation observatories aim to map the CMB with even greater precision, searching for definitive evidence of infinity. If they find it, it would be one of the most profound discoveries in human history, reshaping our understanding of the cosmos and our place within it. But what would an infinite universe mean for us? For one, it would challenge our understanding of time and space. If the universe has no boundaries, then time might also stretch infinitely into the past and future, suggesting that existence itself has no beginning or end. It also raises deep questions about the nature of infinity. Can something truly be endless, or is infinity just a concept our finite minds use to grasp the ungraspable? These questions don't just belong to physicists, they invite all of us to reflect on the nature of reality and our place within it. An infinite universe also has profound implications for the search for life beyond Earth. If the cosmos stretches endlessly, then the possibilities for life, intelligence, and civilizations are equally infinite. Imagine a universe where every star, every planet, and every galaxy is just one tiny part of an endless tapestry, teeming with life in forms we can't even imagine. It's a vision that's both humbling and awe-inspiring, reminding us that the universe is far more mysterious and interconnected than we often realize. As we ponder the idea of an infinite universe, another question emerges. What if the cosmos isn't just endless but endlessly surprising? What if, no matter how much we discover, there's always more to learn, more to explore, and more mysteries waiting to be unveiled? This leads us to the next cosmic surprise, a concept that celebrates the boundless potential for discovery, reminding us that the universe's greatest gift might be its infinite capacity to inspire wonder. What if the universe isn't just vast but endlessly mysterious? What if, no matter how much we discover, there's always another layer of reality waiting to be uncovered, another secret hiding just beyond our reach? This brings us to the 23rd cosmic surprise, the endless frontier of discovery, the idea that the cosmos might hold infinite mysteries with no end to what we can learn. It's a concept that doesn't just challenge our understanding of the universe, it celebrates the boundless potential of human curiosity and the relentless drive to explore the unknown. Think about it, for centuries we've peered into the night sky, unraveling its secrets one by one. From the ancient astronomers who mapped the stars to the modern scientists probing the quantum realm, every discovery has opened the door to new questions, new wonders. And yet, with every answer, the universe seems to present even more mysteries. It's as if the cosmos is an infinite puzzle, one that grows more complex the deeper we dive into it. But isn't that what makes exploration so thrilling? The fact that there's always more to learn, more to discover, more to dream about. Future advancements in technology and science promise to take us even further into this endless frontier. Imagine telescopes so powerful they can peer into the earliest moments of the Big Bang, or quantum computers capable of simulating entire universes. Picture space probes venturing to distant star systems, uncovering alien landscapes and perhaps even signs of life. These tools won't just expand our knowledge, they'll redefine it, revealing layers of reality we can't even begin to imagine today. And as we push the boundaries of what's possible, we might stumble upon phenomena that challenge the very foundations of science, forcing us to rethink everything we thought we knew. But what does this mean for humanity's quest for knowledge? For one, it reminds us that exploration isn't just about finding answers. It's about embracing the journey, the process of discovery itself. It's about asking questions that have no easy answers, venturing into the unknown with a sense of wonder and humility. And perhaps most importantly, it's about recognizing that the universe isn't just something to be studied, it's something to be experienced, a source of endless inspiration and awe. This endless frontier also invites us to reflect on the nature of curiosity. Why do we feel this drive to explore, to understand, to push beyond the limits of what we know? Is it simply a survival instinct, a way to adapt and thrive in an ever-changing world? Or is it something deeper, a fundamental part of who we are as a species? Whatever the reason, our curiosity has taken us to incredible places, from the depths of the ocean to the surface of the moon, and it shows no signs of slowing down. In a universe filled with infinite mysteries, the only limit is our imagination. As we marvel at the endless possibilities of discovery, another question emerges: what if life itself is just as boundless? What if, somewhere out there, life exists in forms we can't even imagine, thriving in places we've yet to explore? This leads us to the next cosmic surprise, a concept that takes the idea of endless discovery to an even more profound level: the possibility of a universe teeming with life in all its infinite variety. What if life isn't just a fleeting phenomenon, a rare spark in the vast darkness of space, but an eternal, intrinsic feature of the universe itself? This brings us to the 24th cosmic surprise, the possibility that life might be woven into the very fabric of reality, existing in some form across all of time and space. It's a concept that shifts our perspective from seeing life as an anomaly to viewing it as a fundamental property of the cosmos, one that persists through the ebb and flow of cosmic cycles. To understand this idea, let's start with what we know about life here on Earth. For centuries, scientists have been trying to answer one of the most profound questions of all: how did life begin? From the primordial soup of early Earth to the complex ecosystems we see today, the story of life is one of evolution, adaptation, and persistence. But what if this story isn't unique to Earth? What if life isn't confined to this tiny blue dot but is a universal constant, as natural and inevitable as gravity or light? This idea finds support in the field of astrobiology, which seeks to understand the origins, evolution, and distribution of life in the universe. Recent discoveries have shown that the building blocks of life, organic molecules like amino acids and sugars, are surprisingly common in space. They've been found in meteorites, comets, and even the clouds of gas between stars. These findings suggest that the ingredients for life might be scattered throughout the cosmos, waiting for the right conditions to come together. Future missions to places like Europa, Enceladus, and Mars could reveal whether life has emerged elsewhere, potentially confirming that it's not just a rare accident but a fundamental aspect of the universe. But what if life isn't just a product of chemistry? What if it's deeply tied to the laws of physics themselves? This is where quantum physics enters the picture. Some theories suggest that consciousness, the very essence of life, might be connected to the strange, interconnected nature of the quantum world. Experiments in quantum entanglement have shown that particles can influence each other instantaneously across vast distances, hinting at a deeper, unified reality. Could this quantum interconnectedness be the foundation for life itself, a universal thread that binds all living things together? The implications of this idea are staggering. If life is an inherent property of the universe, then it might exist in forms we can't even imagine, perhaps thriving in the icy oceans of distant moons. the turbulent atmospheres of gas giants, or even the extreme environments of neutron stars. It also raises profound questions about the nature of existence. Is life a random occurrence, or is it part of a larger cosmic plan? And if it's eternal, does that mean it has a purpose, a role to play in the unfolding story of the universe? As we reflect on these questions, another thought emerges. What if the universe itself is alive? What if the cosmos isn't just a collection of stars and galaxies, but a living, evolving entity, one that grows, learns, and adapts over time? This idea, often referred to as cosmopsychism, suggests that consciousness might be a fundamental feature of the universe, present at every level, from the tiniest particles to the largest structures. In this view, life isn't just a byproduct of the universe, it's an essential part of its very nature. So, what does this mean for us? If life is eternal and universal, then our existence becomes part of a much larger story, one that stretches across the cosmos and through all of time. It's a perspective that's both humbling and empowering, reminding us that we're not just passive observers of the universe but active participants in its unfolding. And as we continue to explore the mysteries of life, we might uncover truths that redefine not just our understanding of existence, but our place within it. As we marvel at the possibility of an eternal, universal life, another question naturally arises. What if the universe itself has no end to its mysteries? What if, no matter how much we discover, there's always another layer of wonder waiting to be unveiled? This leads us to the final cosmic surprise, a concept that celebrates the infinite potential for discovery and the boundless curiosity that drives us to explore the unknown. As we stand on the precipice of all we've explored, from the illusion of time to the mysteries of dark matter, from the mind-bending multiverse to the possibility of a universe teeming with life, one truth becomes undeniably clear: the cosmos is a place of infinite wonder. It's not just a collection of stars and galaxies, but a living, breathing mystery, a canvas painted with questions that outnumber the answers. And this, the 25th cosmic surprise, is perhaps the most profound of all. The universe, in all its vastness and complexity, is a never-ending well of discovery, a frontier that will always beckon us to look deeper, dream bigger, and wonder more. Think about it. Every time we think we've unraveled a piece of the cosmic puzzle, the universe reveals another layer, another secret waiting to be uncovered. The more we learn, the more we realize how much we don't know. And isn't that the beauty of it? The universe isn't just something to be studied. It's an invitation to explore, to imagine, and to grow. From the tiniest quantum particles to the largest galactic superstructures, every discovery reshapes our understanding of reality, challenging us to think in new ways and see the world and ourselves in a different light. Future discoveries will undoubtedly transform our understanding of the cosmos in ways we can't even predict. Imagine what we might learn from missions to Europa or Enceladus, or from the next generation of telescopes that will peer deeper into the universe's past than ever before. Perhaps we'll find evidence of parallel universes or unlock the secrets of dark energy. Maybe we'll finally answer the age-old question: are we alone? Each breakthrough will not only expand our knowledge but also redefine our place in the universe, reminding us that we're part of something much larger than ourselves. But the journey doesn't end with science. The infinite wonder of the cosmos invites us to embrace curiosity, to remain open to the unknown, and to find joy in the process of discovery. It's a reminder that the universe isn't just a place to explore. It's a story to be lived, a mystery to be savored. Whether you're an astronomer peering through a telescope, a student grappling with equations, or simply someone who gazes at the stars and wonders, the cosmos has something to offer. It's a call to stay curious, to keep asking questions, and to never stop marveling at the beauty and complexity of it all. As we bring this journey through the 25 cosmic surprises to a close, let's take a moment to reflect on what we've learned. From the illusion of time to the holographic universe, from the search for extraterrestrial life to the mind-bending possibilities of the multiverse, each surprise has challenged us to rethink our assumptions and expand our horizons. They've shown us that the universe is far stranger, more interconnected, and more mysterious than we ever imagined. And yet, the most exciting part is this: we've only just begun to scratch the surface. The cosmos is a story still being written, and each of us are part of that story. So, as we look to the future, let's carry this sense of wonder with us. Let's remain open to the unknown, ready to embrace the next cosmic surprise, and eager to play our part in the unfolding story of the universe. Because in the end, the greatest gift of the cosmos isn't just the answers we find, it's the questions we dare to ask. And in that spirit, the journey of discovery will always continue, lighting the way forward, one star at a time. As we reach the end of this cosmic journey, let's take a moment to reflect on the 25 extraordinary possibilities we've explored, each one a doorway to reimagining our understanding of the universe. From the illusion of time to the enigmatic nature of dark matter, from the mind-bending multiverse to the tantalizing search for extraterrestrial life, these surprises remind us that the cosmos is far stranger and more interconnected than we ever imagined. They challenge us to think beyond the limits of what we know, to question the very fabric of reality, and to embrace the infinite potential for discovery. At the heart of these revelations lies a single, unifying theme: curiosity. It's this innate drive to explore, to question, and to wonder that has propelled humanity forward, from the first time we looked up at the stars to the cutting-edge experiments reshaping our understanding of the universe today. The cosmos, in all its vastness, is a testament to the power of curiosity, a reminder that the more we learn, the more we realize how much we don't know. And that's not a limitation, it's an invitation to keep exploring, to keep dreaming, and to keep pushing the boundaries of what's possible. These cosmic surprises aren't just abstract ideas or distant theories. They have the power to transform how we see ourselves and our place in the grand tapestry of existence. Imagine a universe where time is an illusion, where parallel realities coexist, or where consciousness is woven into the very fabric of reality. These concepts don't just expand our knowledge, they reshape our perspective, inviting us to see the universe not as a cold, mechanical place, but as a dynamic, interconnected whole, brimming with mystery and wonder. But the journey doesn't end here. The universe is an endless frontier, and every discovery opens the door to new questions, new mysteries, and new opportunities to explore. Whether it's through the lens of a telescope, the data from a particle collider, or the spark of an idea in a curious mind, the cosmos continues to inspire us to look deeper and dream bigger. It's a reminder that the universe isn't just something to be studied, it's something to be experienced, a source of endless inspiration and awe. As Carl Sagan once said, somewhere, something incredible is waiting to be known. That sense of wonder, that belief in the beauty and mystery of the unknown, is what drives us forward. It's what connects us to the explorers of the past and the pioneers of the future. And it's what makes the study of the cosmos not just a scientific endeavor, but a deeply human one. So, as we close this chapter, let's carry that sense of wonder with us. Let's stay curious, stay engaged, and keep asking the big questions. Because the universe isn't just a place to explore, it's a story to be lived, a mystery to be savored. And each of us, in our own way, is a part of that story. Thank you for joining me on this journey through the 25 cosmic surprises that could transform our understanding of the universe. If you enjoyed this exploration, don't forget to share your thoughts in the comments below. What cosmic mystery fascinates you the most? And if you're eager to dive deeper into the wonders of the cosmos, hit that subscribe button and join me for more cosmic adventures. The universe is vast, the mysteries are infinite, and the journey of discovery is just beginning. Until next time, keep looking up and keep